Hi guys, welcome back. So today we are going to be solving radical equations, and as you can see there's a round 1, and wherever there's a round 1 there has to be a round 2. So let's do this. Now the question is, what is a radical equation? A radical equation is an equation that has a radical, but to be more specific, it's an equation where there's a variable inside the radical, okay? Or like using my fancy words, there's a variable in the radicand. Cool. All right, so let's look at these 4 problems and let's confirm that they are indeed radical equations. Equation number 1, radical, variable in it. Cool. Radical equation. Next guy, radical, variable in it. Cool. Radical equation. Third guy, radical, variable in it. Cool. Radical equation. Fourth guy, radical, variable not inside. Fourth guy, okay, so fourth equation, radical, there's not a variable inside, so this is actually not a radical equation. Oh, we have been lied. Okay, so again, just because you see a radical or a square root, it doesn't mean right away like, oh cool, it's a radical equation. Okay, so there has to be a variable inside. We have a variable term, the degree happens to be 1. So pretty much we have a linear equation. So to solve it, if we were gonna solve it because we're overachievers, to isolate the variable term, we're gonna go ahead, work our magic, and do the addition by the square root of 3 by subtracting it from both sides, and that will leave us with 5 minus square root of 3, or negative 3 plus the square root of 5, depending on the mood that I'm in. So now the question is, how do we solve radical equations? Okay, the reason why we're going to have 2 rounds for this unit is because the strategies that we will use to solve a radical equation is based on how many radicals we have. If we only have 1 radical, we handle it some way, but if we have more than 1 radical, then we handle it a different way. So let's do this. So we have 4 fun problems, yeah, because math is fun, or at least we write it out until the very end. Okay, so we have 4 fun problems for round 1, and then I don't know how many we'll have for round 2. Okay, so the directions read solve each equation. When it comes to solving equations, we need to have a clear idea of what kind of equation that is, and that will determine the strategy that we will use. Yes, we're in this section where like we're working with radicals, so it's very easy to just be focused in this unit. But then when you have a review test or the final exam, everything is going to be tossed in the mix, so we have to have a clear idea of the equation that we're working out. If we have a linear equation, we old school it, isolate that variable. If we have a quadratic equation, you have some options. You can solve by factoring, by completing the square quadratic formula, or the square root property. Okay, if you have a rational equation, you work your magic to wipe out the fractions. Okay, if you have a radical equation, how are we gonna handle it? Okay, today we're gonna focus on the case where we are solving radical equations that contain only 1 radical. Okay, so it's a 4-step process. I'll read you the guidelines as we do the first problem. So step 1, the first step is to isolate that radical. Okay, so let's get the square root of x by itself, and then we toss everything to the other side. To undo the addition by 9, let's go ahead, subtract it from both sides, and when we do, that will lead to negative square root of x is equal to 2. Fantastic. So remember, step 1, isolate that radical. We don't have that radical quite isolated because I want to know what the square root of x equals. I can care less what its opposite equals. So to undo the multiplication by negative 1, let's go ahead, divide both sides by negative 1, and when we do, that will leave us with square root of x equals negative 2. So fantastic. So step 1, or goal number 1 complete. Goal number 2, work your magic to get rid of the radical. How? Let me go ahead, zoom in. Okay, so step number 2, work your magic to get rid of the radical. How? You are going to raise both sides to some power. Now the question is, what power? You're going to raise both sides to a power that's equal to the index. So I know that you can read this statement. I should have left it as is. Now it looks ugly. Okay, so we have square root of x, square root of something, meaning that index is 2. So let's go ahead, highlight the index. So someone said, do we really have to highlight the index? You know what, you really don't. Okay, but the reason why I like to highlight it for square roots is because it will highlight why we're gonna do what we're gonna do. To get rid of the index of 2, we're gonna have to raise both sides to a power of 2. And then when we do, the square and the square root undo each other, and that will leave us with x equals 4. Okay, under normal circumstances, I would be like, okay, we're awesome, we don't make arithmetic mistakes, so we box our answer and move on. But check it out. When it comes to solving radical equations, checking is not optional. Okay, we have to check. I'm going to say propose. We have to check our proposed solutions to eliminate any extraneous solutions. Okay, why do we have to check it? Because this squaring both sides, we have properties of equality. You know, adding a number to both sides doesn't change the solution of the equation, and similar for subtraction, multiplication, and division. But we don't have a power rule of equality. No. Okay, so we have to check it. Okay, so I'm gonna put CK for check. I'm gonna write down the original equation. When you're checking an answer to an equation you solve, no matter what section you're in, you're gonna substitute your answer for the variable, and then don't actually don't do anything to both sides. That's like a popular mistake. Plug it in, clean the left, clean the right, and then hope for a match. Okay, so we have 9 minus the square root of x, but we had told the world that our proposed solution is 4, and it needs to check out for my peace of mind. Okay, so we have 9 minus 4 is equal to 11. Okay, so let's go ahead and do this. The square root of 4, who has a calculator, gives us 2. And the question is, does 9 minus 2 equal 11? Of course not. Okay, so it makes me sad. Okay, but if you're like me and you want to finish off the computation, go for it. Difference of 9 and 2 is 7. And to answer the question, does 7 equal 11? Oh, look, I need a Slurpee. Okay, so does 7 equal 11? It does not. Okay, so it doesn't check out, which makes me sad. Now, what is going on? When we check our answers outside this section, if we didn't check out, we will say, oh man, I made a mistake. Well, let's go ahead, find it and fix it. But check it out. For radical equations, we're just going to have to trust our work. So if you like to rush through things, this is not the section where you want to rush. Well, you shouldn't rush through anything, but that's just how I speak. So we're going to have to trust our algebra. Okay, so we know that our algebra is correct. If it checks out, we box it and move on. Okay, if it doesn't check out, then we're just gonna say that 4 is an extraneous solution. Do we have to write this on the test? No, this is just for us. Okay, why am I writing extraneous solution? Oh, that's because it didn't check out. Okay, so extraneous solution, to recap from a previous unit, an extraneous solution, let me just go ahead and put the O. Okay, an extraneous solution is a solution of one of the new equations, but not necessarily of the original equation. So in this case, it's not happening. Okay, so what is the answer? Well, check it out. We have one possible answer. That couldn't fly though. Okay, since we have nothing else to go by, then there's no solution. So we're gonna write no solution. And I know myself, if I don't cross out this x equals 4, I'm going to box it because I get nervous because we are asked to box our answer. So I'm going to just cross it out for dramatic effect. Okay, so again, when it doesn't check out, well, one of two things. We could have either made a genuine mistake, or 2, we trust our algebra and be like, it's just an extraneous solution. Okay, why do we write no solution as the answer? Well, that's because we have one possible answer. There's nothing else to go by. And so there's no solution. Okay, so remember, when it comes to solving radical equations, checking is not optional. We have to check our answer to eliminate any extraneous solutions. So I promised you four fun problems. Let me go ahead and hunt the next one. Alright, so let's go ahead rock and roll with problem B. So we have another equation. We are asked to solve it. So again, we have to identify the type of equation. Oh, we got a radical, variable in it, radical equation. Next question that I'm going to ask myself is this: how many radicals do we have? Oh, just one? Okay, cool. How are we going to handle it? Step number 1, isolate that one radical. Okay, so if you're not with the radical, you got to go to undo the addition by 3. Let's go ahead, subtract both sides by 3. So minus 3, and that will leave us with square root of x minus 1 is equal to x minus 7. Okay, so goal number 1 complete. Okay, goal number 2, work your magic to get rid of the radical. So to do that, we're gonna have to raise both sides to a power equal to the index. So in this case, because we have a square root, then that means that the index is 2. Okay, so to undo the index of 2, we have to raise both sides to a power of 2, or impress your friends, say squared. Okay, when we square both sides, on the left side, the square and the square root undo each other, and that will leave us with the radicand of x minus 1. Okay, on the right side, you're gonna square it however you can. Okay, if you take the multiplication shortcut, let me go ahead, refresh ourselves. I think I said that wrong. Okay, let's go ahead, refresh. I can't think of the word. Okay, so let's go ahead review. Okay, so if we're squaring a binomial of the form a minus b, if this is your question, then this is your answer: a squared minus 2ab plus b squared. Okay, so let me go ahead and do that in a thinking area just to remind myself. When we square x minus 7, first term is of the form a squared, so we're going to take that first term and square it. X times x will give us x squared. First sign is the same, minus 2ab. We're going to take the product of a and b and then double it up. Product of x and 7 is 7x. When we double it up, that will give us 14x. Always positive, b squared, and the square of 7 will give us 49. Okay, if this works for you, cool. And if it doesn't, let me bust out another thinking area. And if it doesn't, then just go ahead in a new line, like right below. Then go ahead, write the problem without the exponents. So write down the 2 binomial factors and then FOIL it out. So do it however you can. Cool. So the radical is gone. How are we going to handle it? At this point, we're going to focus our energy on our new equation and then make a strategy in terms of how to solve it. So in this case, the degree is 2. So since the degree is 2, we have a quadratic equation. And in this case, we're going to solve by factoring. And if it's not factorable, then we got to bust out another technique. When it comes to solve a quadratic equation by factoring, before you can factor, we have to set the equation equal to 0. So let's go ahead, subtract x from both sides, and while we're at it, we'll add 1 to both sides. Moving more than one term at a time makes me nervous, but you know what? If there's a space to line it up under, I'm going to go ahead take it. So let's do this. So when we subtract x from both sides and add 1 to both sides, that will leave us with 0 is equal to x squared minus 15x plus 50. Fantastic. So we have set the equation equal to 0, so we have the green light to factor. Okay, prerequisite step when it comes to factoring is to watch out for common factors. There's no common factor to yank out, so we're good. Now, what kind of problem do we have? Polynomial do we have? Do we have a binomial, trinomial, 4-term polynomial? We got a trinomial. When it comes to trinomials, I'm always going to cross my fingers and hope is the leading coefficient 1. And in this case, it is. Okay? If the leading coefficient is 1, then we don't have to use the AC method. If that's like your favorite technique, then go for it. But if we don't need it, then I'm not going to do it. Okay? Because we have a trinomial and the leading coefficient is 1, we're going to go straight to throwing down parentheses and focus on getting that term. The product of the first term, because this is the first term, the product of the first term needs to give us x squared, and we're going to use variable times itself. Okay, to complete the binomial factors, we want factors of c that add up to b, factors of 50 that add up to negative 15. I know you're smart and the numbers come to you, and I'm smart too, I would like to think. But for me, if I don't see it on paper, it takes me that much longer to find the side. So with your permission or not, I'm gonna go ahead bust out an X game. Okay. Oh, that is the ugliest X ever. Okay, it's okay. So corresponding X game, we want factors of C that add up to B, factors of 50 that add up to negative 15, and if we keep our cool, the factors are gonna be negative 50 and negative 10. So let's check it. The worst thing you can do to yourself is do all this hard work only to later find out that you did it wrong. Let's just nip it in the bud. I think that's the same. Product of negative 5 and negative 10 is 50. Sum of negative 5 and negative 10 is negative 15. Sides are correct, so we have green light to proceed. Okay, so remember, when the leading coefficient is 1, we're just going to toss in the sides to complete the binomial factors. One side number reads negative 5, so one binomial should read x minus 5. The other side number reads negative 10, so that means that the other binomial should read x minus 10. Okay, to solve a quadratic equation by factoring, step number 1, set the equation equal to 0, factor completely, and then apply the zero factor property. If a product equals 0, there's no way around it. One of these factors will have to equal 0. Either the first factor equals 0 or the second factor equals 0. Okay, so let's do this. If the first factor equals 0, after we add 5 to both sides, that's going to lead to a possible solution or a proposed solution of x equals 5. If the second factor equals 0, when we add 10 to both sides, that's going to lead to a possible solution, or impress your friends, a proposed solution of x equals 10. Okay, so the proposed solutions are 5 and 10. But remember, our original equation is a radical equation, so checking is not optional. We have to check our answers to eliminate extraneous solutions. So let's check the first answer. Okay, I know you're awesome and you want to plug in the numbers right away, but I have a tendency to put the numbers in the wrong place, and since I love myself, I'm going to rewrite the original equation. Okay, so we have square root of x minus 1 plus 3 is equal to x minus 4. Okay, you're just gonna have to trust me that I copied it correctly. So let's go ahead check our first answer, which is 5. Okay, so that will give us square root of x, which we are swapping out for 5, minus 1. When we add 3 to it, for my peace of mind, I need it to equal x minus 4. We're swapping out x for 5, minus 4. Fantastic. So on the left side, the square root of 5 minus 1 will give us 4. On the right side, a difference of 5 and 4 is 1. Left side, square root of 4 is 2. And last time I checked, 2 plus 3 does not equal 1. Okay, so that makes me sad. If you're an overachiever, go ahead and finish the checking. Okay, so once again, 5 does not equal 1. So the question is, oh man, did I make a mistake? Or is 5 just an extraneous solution? Again, we have to trust our algebra. Okay, so this is why it's important that you really slow down, especially with those negatives. We trust our algebra. Okay, so in this case, it didn't check out. We know our algebra is correct, so with confidence, we're just gonna say, oh, okay, 5 is an extraneous solution. Okay, I already wrote out the word once, so I'm not gonna write it again. Do you have to cross it out? No, you do not. Okay, you're just responsible for boxing your answers. But I told you in my speech, if I don't cross it out, when I get nervous, I do silly things. Okay, so if I don't cross it out, I'm afraid that I'm gonna box it by mistake. Okay, so when in doubt, cross it out. Cool. Yeah, you could quote me on that. All right, so let's go ahead check our second answer. So same speech, let's go ahead and write down the original equation. And then for our peace of mind, hope that 10 is a solution. Okay, so we have square root of x minus 1. In this case, x is 10. When we increase it by 3, for our peace of mind, I want it to equal x minus 4. So in this case, our proposed solution is 10. On the left side, difference of 10 and 1 is 9. Square root of 9 is 3. And the sum of 3 and itself equals 10. On the right side, difference of 10 and 4 is 6. So to answer my question, is 10 a solution? It sure is, okay, because when we checked it, it gave us a true statement. Now, what is the difference between problem A and problem now? Okay, B. Okay, for problem A, we had one possible answer. It didn't check out. Again, we trust our algebra, so it's an extraneous solution. We have one possible answer. That couldn't fly. Since we had nothing else to go by, there is no solution. Problem now, problem B. We got two possible answers. Only one couldn't fly though. Since we still have something to go by, we're not going to write no solution. Okay, no solution is when you have nothing to go by. But in this case, we do have something to go by. Cool. Alright, let's go ahead and do two more problems and then we're out. Alright, so let's go ahead and knock out problem C. So we have another radical equation. So the question is, how are we going to handle it? So we are always going to ask ourselves, how many radicals do we have? One or more than one? In this case, we only have one. So if you only have one radical, your primary goal is to isolate that one radical. So if you're not with the radical, you got to go. To undo the 6 that's being subtracted from the radical, let's go ahead and add it to both sides. So we're going to add 6 to both sides. And that will leave us with cube root of 2x plus 7 is equal to, what am I? 4. I mean, 2. Sorry. I'm glad that I wrote it correctly. Okay. So now, what do we do after we isolate the radical? Once you've isolated the radical, then your next step is to try to get rid of the radical. Since the index is 3, then we're going to raise both sides to a power of 3. Okay, so we're going to raise both sides to a power equal to the index. So in this case, index is 3, power is 3. They're going to go ahead and undo each other, and that will leave us with the radicand of 2x plus 7 equals whatever the right side simplifies to. 2 to the third power, punch it in or freehand it. That will give us 8. Let's take our time, solve it, and then check our proposed solution. Okay. Now in this case, we're left with the linear equation, so a degree 1 equation. Let's old school it. We want variables on one side and non-variables on the other. To undo the addition by 7, let's go ahead and do the inverse operation. Who speaks like that? Let's just do the opposite. Okay, so we're going to go ahead subtract, and that will leave us with 2x equals 1. For the grand finale, so we could almost leave, to get rid of the times 2, let's go ahead divide both sides by 2, and that will give you any equivalent form of 1/2. And I say equivalent form because what if you do a decimal? Decimals are fine as long as you don't round. So I know we nailed the algebra, I know we did, but again, when it comes to solving radical equations, checking is not optional. You have to check your answers to eliminate extraneous solutions. So that's this check, okay? That's the ugly K. So we have negative 6 plus cube root of 2x plus 7 is equal to negative 4, and then we are checking our proposed solution of x equals 1/2. So again, for my peace of mind, it needs to check out, and if it doesn't, we need to have faith in our algebra and then just say extraneous. Okay, so we have negative 6 plus the cube root of 2 times x, and our proposed solution is 1/2. Let's bring down the rest of the problem, plus 7. And we want to know, does this sum equal negative 4? Okay, so let's take our time. The worst thing you can do to yourself is you take your time on the algebra, but then you rush to checking. Okay, the checking is just as important. Product of 2 and 1/2 will leave us with 1. And we want to know if the sum equals negative 4. Let's take our time. Sum of 1 and 7 will give us 8. And cube root of 8, I think that's 2. Okay, let me do a thinking area. So if we write 8 as a product of prime factors, that will give us 2 to the third power, and then same speech. Index is 3, power is 3, so they undo each other, and that leaves us with the radicand of 2. Okay, or you're just cool like that and generally evaluate it. In this case, we want to know, does the left side equal the right side? And it sure does, because last time I checked, the sum of negative 6 and 2 gives us negative 4. But if you want to finish it off, go for it. Okay, so our proposed solution is 1/2. We checked it, it checked out. So with confidence, we know that 1/2 is a solution. Let's go ahead, write down our fourth and final problem. Okay, we're not even gonna pause it. Problem D. Problem D, we have, oh, check it out, fourth root of 8x minus 3 plus 7 is equal to 5. Okay, so yes, we have a radical equation. Yes, we have that one radical. To solve a radical equation that only has one radical, our primary goal is to isolate that one radical. So let's go ahead, subtract 7 from both sides, and that will leave us with fourth root of 8x minus 3 is equal to -2. Fantastic. So now what are we going to do? Once we have isolated that radical, our next goal is to get rid of that radical. How are we going to do it? To get rid of the radical, we're going to raise both sides to a power equal to the index. So because the index is 4, then we're going to raise both sides to a power of 4. So when we do that on the left side, index is 4, power is 4, they're going to go ahead and do each other, and that will leave you with the radicand of 8x minus 3. You take your time on the right side, free-handed or punch it in, and the fourth power of -2 gives us 16. Let's go ahead and do this. To finish it off, sorry, I was going too fast, okay? So now we're going to focus our energy on our new equation. So in this case, we have a degree 1 equation or linear equation. So let's old school it. So we want variables on one side, non-variables on the other. To undo the subtraction by 3, let's go ahead and do the inverse operation. But again, who speaks like that? Okay, I was just trying to impress my neighbors, okay? To undo a subtraction, let's go ahead and do an addition, and that will leave us with 8x is equal to 19. Fantastic. For the grand finale, to get rid of the times 8, let's go ahead and divide both sides by 8, and that will leave us with any equivalent form of 19/8. Okay, so you can write it as a fraction, as a mixed number, sorry. You can leave it as an improper fraction, you can write it as a mixed number, or you can write it as a decimal. Oftentimes I don't have a calculator with me, so this is why I tend to leave them in fraction form instead of decimal form. But do what you gotta do. Again, decimals are fine, just make sure you don't round your answers. So again, when it comes to solving radical equations, checking is not optional. We have to check our proposed solutions to eliminate any extraneous solutions. So we have fourth root of 8x minus 3 increased by 7 equals 5. And our proposed solution is 19/8. So again, for my peace of mind, it needs to check out, and if it doesn't, we are going to have faith in our algebra and then just say, it's an extraneous solution. So we have fourth root of 8x. Okay, in this case, our x, or our proposed solution, is 19/8. We got to subtract 3 from it. Let me go ahead and extend the radical. When we add 7 to it, I need it to give us 5. Okay, let's clean the left. Product of 8 and 19/8, the quotient of 8 in itself will give us 1, and that will leave us with 19 minus 3, while the fourth root of that plus 7. Okay, let's take our time. Difference of 19 and 3, who speaks like that? 19 minus 3 is 16. We increase it by 7. Fourth root of 16, free-handed or punch it in. Who has a calculator? I don't. Okay. When we write 16 as a product of prime factors, that will give us 2 to the 4th power. And then with confidence, we're like, okay, index is 4, power is 4. They undo each other, and that will leave us with the radicand of 2. So let me close off the thinking area. Okay, so thanks to our thinking area with confidence, we have that the fourth root of 16 evaluates to 2. Bring down the rest of the problem. The sum of 2 and 7 will give us 9, and now will be a good time to bring down the right side of the equation. So when we check our proposed solution, we have that 9 equals 5. I know that you know that 9 does not equal 5. That makes me sad. Okay, we trust our algebra. It didn't check out, so we're just like, okay, 19/8 is an extraneous solution. So again, what is an extraneous solution? An extraneous solution is a solution of one of the new equations, but not of the original equation. So in this case, it's a solution of this linear guy. Okay, so this, we can't use it. So now what is the answer? It's going to be the same speech as problem A. We have one possible answer that couldn't fly. since we have nothing else to go by, there's no solution. Now, you may think like, oh, Miss Doris, are we gonna have a lot of extraneous solutions? No, but since we don't do that many problems as I would like to, I wanna like highlight, like check your answer, or else. Okay, guys, so I said we were gonna do 4 problems for round 1, and that was our 4th and final problem. So we're out. Thanks. Oh, but don't go away because we have part 2. Okay, bye.